We're now going to look at what the book calls sum and product principles. Mainly, the questions that we'll be interested in are of the form, what are the number of ways of making a certain choice? You go to a restaurant and you have a big menu, so how many choices do you have, depending on what exactly is it you want to eat, for example. And to narrow it further down, the kind of questions that we will end up asking are the kind of questions that you as a student should ask yourself every time you see a problem about making a choice is, or counting the number of choices, is when you're supposed to add and when you're supposed to multiply. Okay, this is a common thing to get confused in between in the beginning. But let me just say that I keep saying that there is no theory in this chapter. It's all tricks. And once you do enough problems, it just becomes second nature. Like, I had to put in a lot of effort to explain my thinking when making this video. It's because every time I saw a problem, I just knew how to do it, almost like I don't have to think when I'm speaking. So you should trust yourself that this becomes very second nature, and you don't have to every time think about this adding versus multiplication in your head. But in the beginning, be a little deliberate and put in a little more effort and be more careful. Okay, so that's the preamble. Now, I'll just do examples. So when to add and when to multiply. So what's an example? Say you go to a cafe and you want to have a drink, and on the menu there are 6 hot drinks and 5 cold drinks, and you just want to get one drink because you're a normal person. So how many choices do you have? This is easy. You have 6 choices for hot and 5 choices for cold, and you want to get one, so it should be 6 plus 5. So here I'm adding. So the question is, how many choices of drinks do I have? And the answer is 6 plus 5. And the way in the beginning, you should remember this is as follows. And this is something you have already seen in Boolean algebra. So what is happening? You are making a choice between hot or cold. So you're going to get either a hot drink or a cold drink. So because there's an or in there, you're adding. And in this particular problem, you're getting either a hot drink or a cold drink. And the first one has 6 choices, the second one has 5 choices, and because you're choosing one of the two, you add. Now let's change the question slightly. Say you go to a cafe and now you want to get a drink and a food. And let's say you want to get a hot drink, and there are 6 choices, and you want to get a donut and there are 5 choices for the donut. Now, how many ways are there for you to get a meal? So I'll put this as here. Well, you have 6 hot drinks, and for each of those hot drinks, you have 5 possible choices of donuts. And so the answer should be 6 times 5. And again, the Boolean algebra language comes handy because you're choosing something and something, you're multiplying. So in this particular example, I am doing a hot drink and a bagel. Number of choices for the hot drinks is 6, number of choices for the bagel is 5, and because there is an and in the middle, I'm multiplying. Okay, so and is multiplying, or is addition. Now, before we move on to more complicated stuff, here's a pro tip. Never simplify your answers. Because who cares that 6 plus 5 is 11? If you figure out that the total number of choices is 11, what does it matter? What we are interested in is how you got to that answer. So 6 plus 5 is much more informative than 11. Similarly, 6 times 5 is much more informative than 30. Maybe you came up with the wrong reasoning and somehow got 11. But if I look at 6 plus 5, I know exactly what went behind getting to that answer. So never simplify your answer. Just leave all the sums and all the products as they are. And even on exam, you just leave them as sums and products. Now we move on to more complicated stuff. The book calls this generalized product principle, but that's just jargon. It's nothing new. We are just using the same principles for more complicated problems. So now here is a more complicated problem. I go to the same cafe. I want to get a drink and a bag and a food item, but now I have choices. I have to choose between either hot or cold drink, and I have to choose between a bagel or a donut, let's say. So now my question is number of choices for a drink and a food item. Okay, so then I'll start expanding this slowly. Now for a drink, so I'll get either a hot drink or a cold drink. Then there is an and in the middle. I'll get either a donut or a bagel. And the number of choices for hot drinks is 6. Number of choices for a cold drink is 5. For a donut is 5. For a bagel is 3. And then I'm choosing between, I'm choosing either hot or cold, so I'll add it here. I'm choosing either a donut or a bagel, so I'll add it here. And then I'm choosing both a drink and a donut and a food item, so I'll multiply here. So that's my final answer. So these are the total number of ways of, for me to make choices. You can make this much more complicated. So here's the next level of complication. You can say, I want to get a drink or food item, but I don't want any drink or any food item. I'll either get a hot drink with a bagel, let's say, or a cold drink with a donut. So now I want number of choices for either a hot drink and a bagel, let's say, or I'll get a cold drink and a donut. So now what happens? Number of hot drinks is 6, number of bagels is 3, cold drinks is 5, donuts is 5. Now I'm getting hot drink and a bagel, so I should have 6 times 3. I'm getting cold drink and a donut, so I have 5 times 5. And then I'm choosing between these two options, so I'll add. And so the answer here is 6 times 3 plus 5 times 3. Because as long as you are very explicit with your question and you expand everything out, you will see where the addition goes and where the multiplication goes. Okay, so that's the first level of complication. Then we come to the second level of complication, which is as follows. So again, I'll just do an example. I have the same setup, and let's say I'm looking at only hot drinks. But now I'm going to change the setup. So now suppose I come to the cafe with my friend and we are going to get 2 drinks. I'm going to get 1, my friend is going to get 1. And I want him to choose a drink that is different than mine. Why not? So now my question is, I have to make 2 choices. So I want to make choice 1. This one is for me. Then I want my friend to make second choice. That is choice 2. But I want choice 2 to be separate from choice 1. Now, how many ways are there of making this choice? This like meta choice of choosing 2 drinks such that the second drink is different from the first one. Okay, there's a subtle point here that there is a choice 1 and then there is a choice 2. So the second choice comes after the first one. For now, don't worry too much about this. We will talk about this in a later video. But this is the setup that one choice is made, then the second choice is made, and the second choice needs to be different from the first one. So what are the total number of possibilities? Well, so we are making 2 choices, and so it's an and so I need to multiply. So that's already set up. Now choice 1, I have no prior information to work with, and so I have 6 possible hot drinks to choose from. Now once I pick a hot drink, my friend cannot pick that, and so he has 1 less choice, so his choice number decreases to 5, and that's it. So the total number of ways of making choice 1 and then a choice 2 such that the second choice does not equal the first choice is 6 times 5. So in general, what can happen is that the subsequent choices might depend on the previous choices. And so in this case, you just have to adjust the numbers accordingly. even the previous example that we talked about, where I was picking either a hot drink and a bagel and a cold drink and a donut falls in the same category. So for example, I can choose the drink first, and then depending on whether I choose the hot drink or the cold drink, I'm choosing the food next. And so this is also an example where the subsequent choice depends on the previous choice. So that's the generalized product principle if you want.